Hi, everybody. I'm Tom Sneed. I'm the choir director here at Clay High School, and I also work with a lot of other programs, including our Career Tech Musical Theater and Limelighters. And one of the things that we are trying to partner with the Oregon Schools Foundation is replacing our choir risers. And you might be able to see this one down here on the floor. It's pretty rickety. I would bet it's probably 30, maybe 40 years old. We have 7 sections of these risers that we have to set up every time we do a concert. And not only does the choir use these risers, but a lot of times our athletic department will use them when they have awards in the auditorium. We have various community groups who need to come in, and sometimes they want an elevated platform to sit on or stand on, and we use these risers for a lot of things. They're in really bad shape, and they're pretty expensive to replace. And so we would be very appreciative of any help you can give in helping us get some new choir risers for the Clay High School choir and for all the other groups that use these risers. All right, well, to set these up, it's quite the feat. And you have to be pretty strong to get them open. And this is the part that's always very difficult. And you can see a lot of times the mechanism down there that you have to lock in place, it doesn't lock very well. Some of the risers, the actual tread is loose on the brace that holds it in place. And then over here on this side, we have these connecting parts, and a couple of them, these are all bent. You can see how this one is bent and makes it very difficult for it to connect. Now, these older type risers are really made more for when you're touring and you're going from place to place and you need to transport them easily. The newer risers that are more permanent, made to stay in one location, they are much easier to use. They are on a set of casters, and they fold up with pneumatic pump devices. They help it come down and go up much easier. They have a safety railing that's attached to the back. And matter of fact, we bought a set of these for the Facet Choir. And if you've had a chance to go see one of our concerts at Facet, you'll see these beautiful risers that the choir stands on. So that's the type of riser we're looking to get. They are very safe, much more easier to use, much easier to set up and put into place. Okay, now these choir risers are probably about 30 years old. I've been here for 10 years. My predecessor was here for 10 years, and I've seen pictures of these risers being used even further back than in the last 20 years that we've been here. So I know they're really aged, and they are showing their wear. And what we're trying to do is get something new that's going to be safer, easier to use, and really ready for the next generation to come along and make good use of this type of equipment, much like we have these past 30 years. We've been good stewards, I think, of what we have here, but it's time to put them away and get some new ones to take care of.
Hi, my name is Joe Spolino. I'm the instructor here at Clay High School, and I teach engineering design development. So the current equipment that I have are 2 3D printers. They're Stratasys F170s. These are used as a good entry-level industrial 3D printer. They're a bit outdated. They've been here since I started here 4 years ago. They're good, robust machines. The downside to these is the material is extremely expensive, and they take a long time to print. So one basic print for something small could take a minimum of 7 hours, and I've had prints take up to 55 hours before to print a project for these students. I have roughly 80 students. You can see that could be an issue. So the 3D printer that I'm looking to purchase is from Bamboo Labs. It's a smaller version tabletop 3D printer, but it still has the same floor plan and print area as these larger machines. It uses several different kinds of material that are much less expensive than what we use in these. The main difference is the speed and the quality and the accuracy on those newer, smaller tabletop units far exceed what these can create. The other nice thing is that they're multicolor, so you can get a cartridge that attaches to it and it can print up to, I believe, 4 different colors on one run. Now you can change what colors you want. You can change, you can make them all the same so it prints faster. If you want different layer lines in it. The nice part about it is if I have the students design something with a multi-assembly, so there's 4 or 5 different components to it, they can color code them and then assemble them together, and they could see what was created through what drawing on the assembly. So which of these can I do? These are one color machines.
Hi, I'm Gabe. I'm here at Clay in the Engineering Design and Development program. So I'm going into college for computer science and engineering. Oh, it's been great. I've been able to design 3D models and print them out. I've made different CAD drawings. All right, so one of the projects I've worked on with this is this like mold for the chocolate mold. So I started out with just a block, and then I was able to like just make one of these. I typed out the text, made this by just tracing over an image of it, just like pulled everything out, and then I had to like chamfer everything out like individually so the way the chocolate didn't stick to anything. And so that's the main thing with that, and then I just copied one of these over and just made it all over that, and that's how that went. So you pour some resin or like silicone into this, let it cure, and then once that's done, you pull it out here. I don't have the actual like silicone on me, but then you're able to like pour chocolate into that and pour it out, and it'll have this design on it. Yeah, so actually the thing that let me design this and build it is actually able to export it out into the thing that you can already print it from. So the software we use, Fusion 360, you can both like build it, then export it into like a flash drive. Then they've got something else in the back room where you can, you know, put it onto a tray and then print it out from there. So the material on this is ABS, but like it had also supporting stuff on it, which is QSR. That's pretty much just plastic, but it's spooled up so that way when it goes through the printer, it gets like melted down, and then you just print it out layer by layer, and then it just turns into a 3D thing like this. No, it's really nice. I was able to use this class and help me with other classes so I can have more physical models and be able to, you know, give a deeper understanding with, you know, how everything works.
On this Giving Tuesday, our goal is to raise $1,500 for a Bamboo Lab 3D printer, which is going to increase the efficiency and the accuracy for these students in my class.